Alright, so today we're going to be going over an 820-3330 that is not turning on. So you'll see here that if I plug in the charger, I'm going to plug in the charger and we're going to see what we get and what goes on. So plug this in and take the MagSafe, and as you can see, I get no light in the charger. So there's no green light here. And just so you could see, because you probably couldn't see that with the shit lighting. See, under the microscope camera, no green light. So this is usually a one-wire circuit issue. So let's just go over the one-wire circuit a little bit here before we continue on to the rest. So if we go over to this schematic over here, you'll see that this is the DC in board, right? And you have three lines. You have 18 volts, you have ground, and you have adapter sense, which they misspelled. Great fucking job, Apple. So which one do you think is going to be responsible for the computer seeing the charger? What's going to be responsible for it seeing the charger? What's another word we can use for see? Sense. Perhaps adapter sense. So let's see where adapter sense goes. Adapter sense goes here into this chip. Now we have int and ext, and this is where guessing comes in handy. You have int and ext. What do you think int and ext are for? Ext is going to the charger, which is outside the computer. Int is going to this sys1 wire line, which is inside the computer, the SMC. So sys1 wire goes to this SMC chip. So the whole point of this chip is that when it turns on, when it has power on its VCC pin, VCC, VDD, VIN, anything like that, that means, you know, here's where the chip gets powered. So see, this chip has VCC on the top. That's the power that turns it on. This chip has VIN, voltage in on the top. That's what turns it on. If we keep scrolling down, this chip has VIN on the top. That's what turns it on. This chip has VDD on the top. That's the power it needs to turn on. This chip has VCC on it. That's the power it needs to turn on. So anytime you see VCC, VDD, or VIN at the top, that is power input to turn it on. So for example, my microscope camera here, right? This is the power adapter plugged into the wall, and I'm plugging it into its VCC or VDD or VIN pin. So just so we're on the same page there. Anyway, so this chip over here, I can assume that when I have power on the VCC pin, that its purpose, since it only has two tabs, which are just going between this and that, is that when this turns on, it allows adapter sense, the charger, to talk to the SMC. And I'm just guessing there. Now, what's going to turn this on? Well, what's going to turn this on is when it has 3.4 volts at the VCC pin. So let's see where that comes from. So, and this is something that kills me with a lot of students, by the way. What I'll do is I'll say, put your finger on the screen and follow the line. And holy shit, the amount of people that just stop thinking at this point drives me nuts. So I'll say, okay, so where is this getting power from? And they'll go, and I'll go, no, that's a bidirectional data line to something else. Try again. And they'll go, I give up. And I'll just go, no, I will refund you right now if you say that you give up. No, follow the line. And they'll go, okay, and they'll just say, I don't know. What the fuck? Keep going. So it's, because that's the thing I think a lot of people don't get, is that this is, like 99% of this is like connect the dots. It's like, you know, those little drawing books where you just connect the dots and you make an elephant or you make a castle and shit like that. That's what this is. It's connect the dots. So let's just follow this line. Ding! It comes from this thing over here, and let's see. So what does this thing do? Well, let's say I'm not sure. Let's say I'm not even willing to take a guess as to what it does. So we have 3.42 volts, which is a main power line, PP for power line, PP3V42 on pin 5, SMC, BC, AC, OK coming in on A and B. We have grounds, and then we have this. So again, my guess would be that this is input. If input is present, you get output, and 3.42 volts turns this thing on. But let's say that I'm completely 110% unwilling to even make a guess, like so many people are that I wind up teaching. Well, let's just say that you're not willing to make a guess. You refuse the possibility of being wrong. Let's just Google the chip. What the hell am I Googling this chip on Yahoo for? Fuck Yahoo. Give me Google. Give me a real search engine. Here we go. Real search engine. All right, so let's see if I can find a data sheet for this piece of crap. If we can find a data sheet for it, then we'll try to see what it does. And as with most things that we work on, there is no data sheet. You know, sometimes you can just delete a couple of numbers and get a data sheet. on something that's similar or close enough, and that's what I'm doing. All right, so here we go. What do you do? Data sheet, English version. Yes, English version. Yes, yes, yes. English. Give me English. Awesome. Give me that PDF file. All right. So what does this do? To input and gate. In A, see? In A, in B, out. Why? Okay, so let's say that it's not obvious at this point that this is in and that's out. Let's scroll down and see if we get an idea of how this works. So we have L and H, and this is another point here where you got to be willing to guess. If you're not willing to guess, you're just going to be fucked throughout your entire life. So we have L and H. Well, since we're dealing with voltages and signals, I'm going to take a guess that means low and high. So if A and B are low, Y, which is out, will be low. If A is low but B is high, we have voltage here but no voltage there or something, or voltage here but no voltage there, output will be low. If A is high and B is low, we still get nothing on output. So the only way this is going to work is if A and B are both high, we get output on Y. So now let's take a look back at our circuit here. So we have SMC, BC, AC, OK. Now this signal is tied to the point where what's going on A and what's going on B are the same thing. So if SMC, BC, AC, OK is present, I will get output on Y. So here's what I'm going to do so I can bypass most of this. The first thing that I'm going to do here is instead of measuring if PP3V42 is present and then measuring if SMC, BC, AC, OK is present, I'm going to skip ahead a little. I'm going to see if I have voltage on pin 1 of U6900, because if I have voltage on pin 1 of U6900, then I can skip all this because I know that this is working. This is also why I say that you need PP3V42 for the one-wire circuit to work. So PP3V42 up here powers this logic gate. If this logic gate does not have power, it will never shoot out power to this, which means this will not have power. If this does not have power, that means that the charger cannot talk to the SMC, and if adapter sense, or adaptor sense, from the idiot that spelled it like that, cannot talk to the SMC on this line, you'll never get a green light, it'll never turn on. But let's just skip ahead a little and see what we have on U6900 here, shall we? So let's find U6900. So I'm going to open this board view software. I'm going to open up the board view, U6900, and it looks like that is over here. So I want to measure pin 1 of U6900. So now let's find that on my microscope, and we're going to measure and see what voltage we get there. And you probably won't see the voltage because I'm going to get in the way of the multimeter. But what are you going to do? What are you going to do? So let's find this little shit. Now what's interesting here is that it looks like it's actually soldered onto the board crooked. So maybe somebody tried to do something themselves? I don't know. Looks kind. What do you guys think? This looks a little funky. So I get 3.378 volts there, which means most of the one-wire circuit is working just fine. And that sucks. So let's take a look at this area and see if there's anything telling. So if we just look back at the schematic here, you'll see that there are still things that could cause this to not work. If this pull-up resistor is not working, so this is 3.4 volts coming in over here. If this pull-up resistor is not working, this one-wire data line may not work. So we can check R6929, which is probably going to be, yeah, this thing over here. So we can check that. We can check that. R6929. 2 kilo ohms, that's good. Okay, so now we're kind of out of the realm of being a one-wire circuit issue. Now I kind of wonder, is it an SMC issue? So remember, this is a data line that goes to the SMC. This one wire goes to the SMC. So the SMC does have to tell the charger, hey, I see you, turn on. So now this begs the question of what turns on the SMC. And look over here, we have a signal called SMC reset L. Now, I want you to think about what reset does on a desktop computer. If you hold down the reset button on your desktop computer, I don't mean if you tap it. If you have an older desktop with a discrete reset button and you just hold it in, you hold the reset button in for 20 seconds, the machine is on, but it's not doing anything. It doesn't post, it doesn't show you anything on the screen, nothing happens. Reset is not just, it's not a signal that if constantly asserted will actually reset anything. It will keep it in a reset state, which is a blank state. It's like a blank slate. Trying to think, what's a good analogy here? I'm out of good analogies today. Oh well. So if the reset signal is asserted, but you keep it asserted, it will never allow the device to turn on. So let's see if SMC reset L is up, because if SMC reset L is not high, then it's asserted. Just keep in mind, the underscore L means that that signal, the reset signal, is asserted when the voltage is low. That's what the underscore L at the end is for. So let's check out SMC reset L and see. First I have to do is find out where SMC reset L is. And here we go. Now this is one of those times where I actually hope the reset signal is low, because if the reset signal is high, that means it's probably the SMC. Fuck. And let's go over another way that you can tell that it's the SMC. Which it is, by the way. It's an SMC. You fucking piece of shit. PPBUS G3 HOT, which is the main voltage, is usually 12.56, and here I'm guessing it's going to be 12.23, or yeah, 12.2. All right. Let's go over that. Let's go over what I'm talking about here. What the hell is Lewis talking about here with the voltages? All right, so we are going to go up here. PPBUS G3 HOT. It says 12.8. It's never 12.8. It's 12.5 to 12.6. The schematic is bullshit, but it's not supposed to be 12.2. So let's go over where PPBUS G3 HOT is created, so that we can go over how this is set, why that voltage matters, and how this works. So ISL 6259 over here is part of a buck regulator that is going to take the 16 or 18 volts from the charger up here, and these transistors will do switching, which will turn it into 12.6 volts. Now you may notice this ISL 6259 chip gets used. This chip gets used both for MacBook Airs, which work on 8.1 or 8.5 volts, and it gets used on here, which it works on 12.5, 12.6 volts. So you may notice that the same chip gets used, and you may wonder, well, how is that same chip used on a system that works off of 8.5 volts and a system that works off of 12.6? Well, let's take a look at a MacBook Air schematic here so that we can get a little bit of an idea of what's going on. So this is a different MacBook. We're going to look at a MacBook Air now. So my question to you is, what is different between the MacBook Air, which works off of 8.5 volts that's using this chip, and the MacBook Pro that works off 12.6 volts that's using this chip? What is different? Do you guys notice a difference yet? It's one of those things that, I'm going to be honest with you, I forget about constantly. So I'll know it in my head at a certain point in time. I'll know that this is true, and then like a month later, if it's not something I care about, I got to look at the schematic again to figure it out. So I'll give you some time. All right. I get it. You don't know. Charger cell. Look at charger cell. On a MacBook Air, there is a 100 ohm resistor between charger cell and ground. On a MacBook Pro, there is a 1 kilo ohm resistor between PP3V42 and cell. See that difference? See, and this is what sets the voltage. So that's going to set the voltage up to the 12.23 or the 8.1 level. So that's going to set whether it's 8.1 or 12. Now, after that, it talks to the SMC to determine the voltage, and I'm going to tell you how you figure this out. Every single time I've had a board that had a dead SMC, meaning there was no green light, the one-wire circuit wasn't working, every time I have a board where the SMC is not functioning, what I will notice is that the voltage is lower than it is when the SMC is functioning, which tells me that the SMC is going to tell U7000 to set the final voltage. So if you look at this, SMBus charger SCL, SMBus charger SDA. This is a data line where the charger, not with the charger, what the fuck am I saying? This is a data line where the SMC is going to speak to U7000, the battery charging chip, right? So this is where the SMC is going to talk to this. Now the SMC is going to set the final voltage. So first the ISL is going to turn on. It's going to check charger cell. Am I 8 volts today? Am I 12 volts today? What am I today? What voltage am I? It's going to set the mode. After it sets the base voltage, then it's going to talk to the SMC to get the final voltage. And if the SMC is fucked, you will never get the final voltage, which is why on a board that has a working SMC, with a board with a working SMC, you will get 12.56, and with a board with a dead SMC, you'll get 12.22. If you want to test this, simply remove the SMC from a working board and measure PPBUS G3 HOT, and you'll see what you get. This is enough for me to figure that the SMC is probably dead, which sucks. That fucking sucks. Because that means I have to replace it, and that's the shittiest thing there is to do, because it takes forever. You can only get SMCs off donor boards, because they come with programming. And taking this thing off and putting 96 fucking balls on the other one is such a fucking pain in the ass. Like a big pain in the ass. I hate this shit. But what are you gonna do? You don't get to like every part of your job. So let's start with the heating process. We're gonna heat off this shit around the chip. And I have a board that I have in the oven over there. So that's gonna help at least get the SMC off the donor board a little bit easier. So let's heat this shit and get rid of all that edge bonding. Now, it would be really cool. What I think would be best, above all else, is if there was just a cracked ball under the SMC. But that's not going to be the case. It's never the easy thing. When you work here, it's never the fucking easy thing. Don't you dare ever assume it's going to be the easy thing. Especially if you're Jason, because I purposely leave all the annoying shit for him. I don't know how I wound up sticking myself with this one. I probably wasn't paying attention. Either that or he grabbed all the easy stuff. Alright, so I've heated that to the point where I'm comfortable trying to remove the edge bonding. Now sometimes this comes off in one piece. And those times are the times where I'm not doing a video on camera. When I am doing a video on camera, it comes off in like 30 pieces and sets a horrible example for you. Which is what's going to happen here. But again, I don't. What are you gonna do? Yeah, this is so fucking annoying. Like this shit that they put around the chip. Like it would kill you to fucking come off in one piece. It really would. It's gonna leave shit under the chip. It's gonna make removing the chip a pain in the ass. And honestly, I don't give a fuck about this chip because I'm not trying to reflow it. I'm trying to replace it. So if I remove this chip and it comes off nastily, I don't care. This is going to go on the floor. I really should try giving that chip a solid reflow before replacing it, just as a Hail Mary. But I don't think that's going to be the issue. Now the thing is, a reflow works if there's a cracked solder ball, and a reflow will work if there's corrosion under the chip, but the chip itself is fine, so in cases of water. So when I see a little bit of liquid around the SMC, I'm totally okay giving it a reflow. But this board has no sign that it's ever been liquid damage, which means that if I do that, I'm most likely wasting my time just because I want it to be something simple. I want it to be something that can be fixed easily rather than putting 96 little balls and doing all that other horse shit. But again, it's not about the repair, what you want the problem to be, it's about what the problem actually is. And in this case, the problem is it's not the balls, it's the chip. But my stupid hopeful soul is still going to waste time reflowing because it's that stubborn, it's that lazy that I'm actually going to do more work just to avoid having to do the work that I'm inevitably going to have to do anyway, which is such a sad trait. But that's what I'm going to do. That's what I'm going to do because I'm fucking stubborn. Anyway, so let's go here. Flux you up. I will flux you up, mofo. And I will heat you. And you will get heated. And you will get reflown. Let's give this a little bit of time. At the very least, the reflow will make it easier to remove it since the board will already be warm. The one positive that will come out of this display of stubbornness. Get away, plastic. Go away. Alright. Now we see if my Hail Mary did anything, which it probably didn't. So we see if my reflow fixed it. So we're just going to cool the SMC off a little bit. Cool this area a tiny bit. Just enough that I cannot feel too guilty for plugging it into a charger. Let's cool it off with a little bit of I'm not going to keep it on too long. I'm just going to see if I get a green light. Which I don't, because that SMC is dead. Duh, obviously. Anyway, so let's remove that piece of shit that I should have removed in the first place. Pull you off the board. Now there are other things that can cause this. It also can be caused if the power button is stuck pressed down. That puts the SMC in a reset mode. However, what you have to think about is the fact that if the power button was stuck pressed down, we would also have an SMC reset signal that was low, not high. Come on, come off. Okay, SMC is off. Now we clean the board and drop the multimeter on the floor. That's why the thing can't stand up properly anymore. Now we have to take the SMC off of the donor. Now, you may want... I put it in the oven for a while because I wanted to I wanted it to be easier to remove the edge bonding and also easier to remove the SMC. So I figured if I left it in the oven for a while, that would just make my job a little easier. Let's see if I was right or if that was just a dumb thing to do. So this is the SMC over here. I'm removing off the edge bonding. Here I don't care if it comes off in like 30 pieces because I'm not reflowing it, I'm just removing the chip. Especially, I don't care if I scratch this board. I don't care if I rip pads off this board because this board is a piece of shit donor that's dead anyway. So I'm going to add some flux. You can see that this board is so hot that the flux is already kind of activating. Now it should be easier to remove the SMC from this board because the board itself is already really hot. Had it in the oven at 350 Fahrenheit. Not solder melting temperature, but warm temperature nonetheless. It should ease the process of getting the chip off. Yep. Okay, so now we're going to take this chip. Yes, I did just drop the board on the floor because it's hot and I don't want to touch it. Take this chip, I'm going to put it in my... Hey. Where'd you go? Don't you try to run away from me, little SMC. Get back here, you fucker. Alright, so put this in here. This is why I cry a little inside when I see that people on eBay are doing this shit for like 70 bucks. I mean, not even the reballing thing, because this reballing shit is not something I would do for 70 bucks. But like, the diagnosis, plus all that, I just don't get it. Okay, so now I want to make sure that every single one of those pads can attract solder. So I'm going to remove all the old, scrub in some new. So let's see which pads are the pads that don't want to be able to immediately take solder. We're just going to have to do a little bit of scraping at those. And this is one of the parts that just sucks about doing the SMC, because this is just manual labor. There's no brain here. This is just repetitive, boring-ass manual labor. So this one doesn't want to take any solder, that one doesn't want to. The ones that look a little bit grayed out are the ones where I just scrape a little with the tip. Yeah, I scrape away the junk, oxidation, any of that shit. You couldn't see. Alright, you'll see the rest of the ones that I do. See, scrape. I want to know that they have the capability of taking solder. See, in the beginning, without scraping, it doesn't. But then after a little bit of scraping, it does. The whole idea is I want the solder paste to be able to stick to the pads nice and easy. So I go over these pads. Don't spend too much time in any one pad. You don't want to rip them and you don't want to burn the SMC. Then you have to start this whole process over again. Now, I would say there's very little worse in the world than having to start this whole process over again. I guess, you know, maybe cancer and stuff like that, but... Also be careful of the chip peeling on the corners. Alright, so at this point I feel like I've gotten just about every one. So now what I can do is get my wick. And do this. And now I have nice flat pads that I know can accept solder. Now some of them may have a little bit of solder left on them, and honestly that's fine with me. That's the whole beauty of using solder paste instead of solder balls. If there is a little tiny little bit of solder on an individual pad, that means that there's less space for more solder paste to go in there, which means it'll even out. You know, the more solder you have on a pad, the less solder paste will fit in the hole, and you'll get a nice even-sized thing. Whereas if you're using solder balls, well, every solder ball you're putting in there is going to be the same size, which means if you have solder on a pad, then you're going to have missized stuff. So I like to use solder paste instead of solder balls because I don't see a reason to make my life harder. I've used solder balls when doing large BGA chipsets because there sometimes it's easier. But I mean, I never do large BGA chipsets anymore because that work is a nightmare. Having to use the Zomo and getting bad chips from suppliers and fuck that shit. There's no money in that crap. But I mean, like this thing, I see people doing it for like $70 on eBay, and again, like the people that are arguing with me that there's great money in that are the people who are doing that for $70 on eBay, and then paying like 6% eBay, 3% PayPal, free shipping. Like, what did you make off of that after paying an employee? Like $10? Anyway, so here, get rid of all the shit. I get my stencil, clean out my stencil, my beautiful stencil. I clean the stencil by putting it to the air filter and just running the hot air at full temperature, full pressure. Nice, beautiful empty stencil. And then a little bit of alcohol. And whatever didn't pop out, I can just pop out with my tweezers. If there's a solder ball that's stuck in a hole, you can also ultrasonic these, but make them look a little nicer. But sometimes even after you ultrasonic it, it still has solder balls stuck in the hole and shit like that. Some flux will help the solder flow away. And okay, we're just about there. So it's going to go on like this. Now I'm going to tape it using Captain tape. Captain tape is heat-resistant tape. Don't try this with Scotch tape or packing tape or anything like that. Captain tape is that orange stuff that you see inside older MacBooks. And older laptops. And one more piece of tape. Keep in mind that there is a slight chance that the issue is not the SMC, and also there's a really good chance that the SMC I'm putting on is actually dead because it came off of a dead board. So keep in mind, all this work could be for nothing. So we're going to get our solder paste ready. I sell solder paste on the mail-in.repair site. It's a Syntech solder paste, SYNTECH, if you're interested in buying the same thing I have. So this stuff here, I also have links in the description for most of this stuff. It's paste, but that will turn into little solder balls in the shape of the stencil. So I do this. Then I find a paper towel, which I don't have because they're always stolen. Let's find a paper towel to wipe this off. All right. Okay. So I just wiped off my tweezers with alcohol and paper towel. And I'm going to do now this. I'm going to wipe off with no alcohol, just a paper towel, just to remove the excess paste. I want to have a nice flat layer of solder paste here. Now we're going to heat it. And once we heat it, all of that is going to turn into nice solder balls. Excited? You should be excited. I'm excited. Now, in an ideal world, they're all just going to turn around and be happy. If you're using individual solder balls, what's going to happen is they're all going to pop out and they're going to combine with the other balls and you're going to curse and scream and cry. But I'm using solder paste, so that's not going to happen. It's going to try to do that, but I'm just going to stare at them with hatred, like at this motherfucker here, and tell him that he better get back in the hole. That's right. That's right. So now we got to get the ones on the left that are melting slower than the ones on the right for no good reason. Okay, and we're going to get the ones on the top that are melting slower for no good reason. And you're just going to have to move this thing around. Move the hot air around. And you're just going to have to find the angle that melts the balls that don't want to melt. It's not going to make sense, because you're going to be almost pointing away from them, and it's when you're pointing away from them they melt. And fuck if I understand the physics behind any of that. So then I'm going to pull it away. Now we're just going to take a look at the areas that didn't melt. Add flux. It's going to activate because this is boiling by now. And go back in. Because once the flux burns away, the balls start to look really shitty. And we're just going to point at the sections where the balls did not melt. We're going to make them melt. So they melted. The ones on the left melted. I just got to get these ones over here. Melt, you piece of shit. Yes, excellent. Now the hardest part of this whole thing is pulling the stencil off without all the balls coming with it. So the first thing I have to do is pull the tape off. Now the balls have expanded, and also there's so much flux that's so sticky that even if the balls hadn't expanded, the stencil is just going to be stuck there. So what I do is I put my tweezer under here, under the left corner, and I lift slowly while heating. Slowly up, straight up, in one foul movement, like a seesaw, not wobbling back and forth. And then we see what we have, and I have every ball besides one ball, which is fucking fine. I'm just going to grab a ball from the side. First thing I do is I'm just going to move some of this shit out of the way. So every ball melted, so that ball came out. Okay, whatever. Fuck that ball. We're gonna grab a ball from the side over here. Oh, these are the broken tweezers. Fuck. We're gonna grab a ball from the side over here. Hey, now another ball came off. Oh, great. Well, hopefully you have better luck than I do. Okay. No. Yes, ball. Now I grab another one. Yes, ball. Alright, so we're just about done. Make all the balls dance. And we have this one over here that thought it was going to be slick. Get the fuck out of there. I'm just going to check for shorts. Visually inspect and check for shorts. And I don't see any. So, now it's time to put this piece of crap on the machine. Okay, this is my nasty, nasty board. Now keep in mind the orientation. So this over here is a straight line. Wow, that is out of focus. Yeah, the camera's not matching the focus of the oculars there. There we go, fixed. I'm just going to clean some of the excess flux off of my SMC with the Q-tip, because there's some on the top that's going to make it hard to work with. I'm doing it over the desk rather than over the board because I don't want to mess up the board. Blow it off with the alcohol. Alright, so let's take a look at orientation here. So this is going to have to go like this. Okay, that makes enough sense. So now we add some flux to the board. You know. Okay, that's my SMC. Now I'm going to push down. And here's the thing. The way regular machines have these little squares or these little L-shaped brackets around BGA chipsets so that you can align them. Apple think they're special, so they don't do that on their board. So what I do is I put it down and I hope it's aligned. And then when I'm moving it back, I'm pushing down hard. And when I'm moving back and forth, if the chip is aligned, it's not going to move more than the diameter of a single pad. And that's how you're going to know that you're in place. But even once you do that, you still just kind of have to hope and pray. Because again, Apple, unlike every other manufacturer on planet Earth, does not put the fucking lines around the chip so that you know if it's aligned. Which is BS, but that's fucking Apple for you. It sucks, but again, this is an Apple product. You can't expect the manufacturing or the repairability or any of that to make any sense. If you do, you're a fool. This looks like it's sticking up in a funny way. It is sticking up in a funny way. This looks really odd. Let's examine it from the side, shall we? Yeah, it looks fucked up. The angle of the microscope doesn't allow me to do better than this. Yeah. This is where a Barlow lens would come in handy. Yeah, it looks pretty fucked up. It's not sitting flat. Alright, let's maybe give it a little bit of a reflow. You know, before I give it a reflow, let's just see if I get any reaction. Just out of curiosity. Holy crap. Turns on. How the f... You see what I'm looking at here? The shit's literally lopsided. This looks like shit. And here's the part where I'm going to do what I always do, which I should never fucking do, which is, it literally works, but it doesn't look good. So what I'm going to do is I'm going to take something that works, that actually works, but that isn't perfect, and try to make it perfect. And I'm doing this on camera for a reason, because I want you to understand why you should not do the same thing. What I'm going to do is I'm going to take something that works, try to make it perfect, and I'm going to kill it trying to make it perfect. Just watch. This way you'll learn from my idiocy. So this actually turns on. I got a light, I had fan spinning. But I want the SMC to sit flat on the board. I don't like the fact that it's not sitting perfectly flat. I don't like the fact that the balls are sticking up on one side. So I'm going to try to make it perfect. And when I'm done with this, it's going to be dead. Just you watch. Just tapping it. Let it move into place. Cool it off. Cool it off. We'll see if this looks any better. So this looks 10 times better than it did before. It looks better. However, I bet my balls that it's actually dead now. Because I tried to make it perfect. But there's only one way to confirm that. Plug it in. And, it works. Go figure. Strange. See? Fan spinning. Light on. I give up. Nothing makes sense anymore. So, this definitely has to go through the cleaner, because that does not look very nice. At least with all that flux there. This really should get all the flux cleaned off. But you got to see soldering an SMC, you got to see screwed up soldering of an SMC, you got to see fixing the screwed up soldering of an SMC, you got to see the diagnostic process to figure out that the SMC is not working. So that's it for today, and as always, I hope you learned something. So just to recap, when the SMC is not working, you're going to see a voltage on PPBUS G3 HOT that is about 3% lower than what you would expect to see. And when that's the case, the SMC is either not on or itself bad.